Alright, so at what point on the parabola y is equal to 3x squared is the slope of the tangent line equal to 24? So to do this question, I'm going to be utilizing the first principal method to find the derivative function. So recall that the first principal method, f prime of x, the derivative function, is equal to the limit as h approaches 0, f of x plus h minus f of x over h. Okay, so you can notice here that limit as h approaches 0, this expression here becomes undefined, so we need a way to cancel out the h on the denominator. So to do that, we need to simplify the numerator until we get a common factor of h, and then we can cancel it out. So my function here is 3x squared. On my numerator, I need to first figure out what's f of x plus h. So if I plug this in, you get 3 times x plus h squared. Now, just to kind of make your lives a lot easier, try to memorize this expansion, a plus b squared. Right? It's a binomial expansion, and in this case, you would get a squared plus 2ab plus b squared. Okay? So I'm going to utilize the same notion here for the x plus h, and if you expand it out, you should get x squared plus 2xh plus h squared. Okay, and if you expand this out even further, you should get 3x squared plus 6xh plus 3h squared. Okay, so that's f of x plus h. The next term you want to look at is negative f of x, which is basically negative 3x squared, right? And the collective term f of x plus h minus f of x is basically equal to 3x squared plus 6xh plus 3h squared minus 3x squared, right? I'm just currently working with the numerator, and you can notice here that the 3x squared and the negative 3x squared cancels out, and what you're left with here is 6xh plus 3h squared. Now you can notice here that both of these have an h in common, and we said that we wanted to cancel out this h on the denominator by getting a common factor of h on the numerator. So I'm going to factor out an h until you get 6x plus 3h. Now I'm going to go back to my limit. F prime of x is equal to limit as h approaches 0, and then I'm going to plug this back in. So you get h times 6x plus 3h over h, and now the restriction is gone because we can cancel out the common factor h. Once we do that, then we can let h finally approach 0 because of the fact that there is no restriction. So f prime of x here is equal to 6x plus, when h becomes 0, this cancels out, and you just get 6x. Okay, so we know that the slope of the tangent, the derivative function f prime of x, is equal to 6x. You want to figure out at what point is the slope of the tangent equal to 24. So you're going to let f prime of x equal 24. So 6x is equal to 24. So therefore x is going to be equal to 4. Now that x is equal to 4, you need to find the point at which the tangent line is equal to 24. Well, a point is going to have x and y. So all you have to do now is you need to substitute x is equal to 4 into your original equation to find the y equivalent. F of 4 here is 3 times 4 squared, which is 3 times 16, which is 48. So therefore the point here should be 4 and 48. Okay, and that's when the slope of the tangent line is equal to 24.